Okay, guys. So in the previous class that we had, we managed to consider working with our algebraic equations as an introduction, how to just solve a normal algebraic equation. Still on these equations, there is a part that we are going to need working or involving powers. What is it that we are considering there? A power is involved. Let us consider back in our revision. Remember, we once talked about exponents. I want you to get back to the exponents and just have an understanding there. You were having a certain consideration 2 to the exponent of 3. Then you simplify 2 to the exponent, that is 2 times 2 times 3 times. 2 times 2, which is 4 times 2, which is going to give us 8. That is, it is multiplying itself 3 times. 2 is multiplying itself 3 times. That is going to give us what? 8. All right. I want us to have another part again. 3 to the exponent of a 2 is equal to what? You're multiplying 3 times, it multiplies itself 2 times. 3 times 3, which was going to give us a 9. 3 to the exponent of 2 is equal to a 9. Okay, this is something that you can simplify and obtain an answer. But now, from those exponents that we were working, as usual, just as a normal question, 5 to the exponent of 3, simplify. You multiply 5 times 5 times 5, 3 times, you obtain 125. Now, they are taking those exponents, having them as equations. Remember, an equation, there is an unknown to be calculated there. So they are now removing these two that these three that we used to calculate. That we are already given before. They are now giving you like this, 2 to the exponent in place of, instead of them giving you this, they are going to set an unknown value for that. Maybe 2 to the exponent of x is equal to this 8 that we are seeing. And they will ask you to find or to solve for x. It's now an equation when it is like that. Solve the equation. Remember what I said on the introduction. When the left-hand side is equal to what is on the right-hand side, it's an equation. It is equal to this. So it's no longer, but this is what we had. We saw that previously, that it was a 3 that we had there, that we raised to the exponent, 2 to the exponent of 3, we got an 8. So if you know that, you can see that, okay, the number that I need here, which number am I going to need here so that I obtain this 8? Which exponent that I'm going to, which power that I'm going to put here? That's a 3. That's a 3 that we are seeing here. So meaning to say our x is supposed to be a 3 for this equation to be true. So it is something that we are looking into, just like what I said, an equation, you can just look into it and, okay, the answer is. But they want you to have some stages, some calculations, some workings. So you're not just supposed, okay, x is 3. You're supposed to show working. So how are we going to solve these equations? It is considered that in whatever condition that you are going to work with exponents, I want you to consider this. There is no way that we have a 2 to the exponent of 3, which is equal to 2 to the exponent of 4. There is no way like this. It is impossible for these two to be the same as long we are in the base of 2 and the base of 2. It means also these exponents are supposed to be the same. So for these two to be equal, this must also be raised to the exponent of 3. We must see the same base, as we can see, and also we must see the same exponent here. We must have the same numbers for these two to be equal. So this can be an advantage when you are solving these equations. You just need to make sure that these bases are the same. So you just make sure you have the same bases, all right? express in the same base. That is the condition, in the same base. So if we are to express in the same base, let's see what we have here. Already, the left-hand side is having this condition of 2 to the power of, the base is already 2 to the power of x. So that one, we're just going to leave it like that. Then we focus on this 8. How are we going to write this 8? Because 8 is not written as a number to the power of just 8. So that is where you have to think of now. How can you write this 8 as a number in the base of 2? As a number in the base of, because already the base is there. How can you write 8 in the number of base of 2? So 8 in the base of 2 was taken from 2 times 2 times 2 3 times. It was taken from 2 to the exponent of 3. 2 multiplying itself 3 times. So this 8 here can be written in the base of 2 as 2 to the exponent of a 3. It can be written in the base of 2 as 2 to the exponent of 3. Now I want us to see something. Like I said, if we have got this condition of the same basis, we are going to see that also the exponents are the same. We've got same exponents also. So if that is the condition, as long you see that these bases here are the same, this one, the 2 and the 2, as you can see, they are the same. It means, therefore, our x will be equal to 3 because these bases here are the same. So it is by default that this x will be equal to 3. Also, just like 3 is equal to 3, the powers, the exponents there will be the same. So therefore, our x is going to be equal to a 3, which is the exponent there. You just take those exponents. They are supposed to be the same also. If the bases are the same, the exponents must be the same also. So this is the technique that you are going to use when solving these equations. All right. So if you are to consider, that was just like write, copy, and complete. We're going to talk about that. We just need to work on these equations. If you check, they are saying now use Karina's method and solve for x of the following. All right. In each of the following. So this is the concept of having the same bases. As long you have the same bases, it follows that the exponents will be the same. So let's consider question 3a. 2 to the exponent of x is equal to a 32. So already 2 here is a base raised to a certain power. So we are not going to focus on that 2. We are going to put our focus on the 32 that is remaining there. How can we write this 32 in the base of 2? Remember your exponents. 32 was 2 times 2 times 2, 5 times. So if you do not understand, just take your calculator. 2 to the exponent of 1, that's a 2. 2 to the exponent of 2, that's a 4. 2 to the exponent of 3, that's from your calculator. You see, until you get a number that is what? That is equal to 32. You see, okay, it's on 2 to the exponent of 5. You try 2 to the, until you get a 32. So it's on 2 to the exponent of a 5. 2 multiplying itself 5 times. The moment that these bases, the moment we see this, that the base of 2 and the base of 2 are the same, these bases, therefore, our exponents are also the same. So hence, x is equal to what? To 5. Just like that. You take the x, which is equal to the powers, will be the same. Exponents will be the same. So that is the condition that you can use, and you can even check that and see that is exactly the value of x that you need. 4 to the exponent of x is equal to 16. Can we write 16 in the base of 4? Yes, we can write that in the base of 4. 4 times a 4 gives us 16. So meaning to say it is 4 being raised to the power of 2. 4 is multiplying itself 2 times. As long these bases here are the same, therefore the powers, exponents will be the same. So therefore, our x is going to be equal to what? A 2. We have got the value of x. Same concept that we are seeing on our question C. Can we write these in the same basis? That is the question. 6 to the exponent of x is equal to 216. Can we write 216 in the base of 6? Yes, that is possible. So like I said, you can even try on your calculator. 6 to the exponent of 1, you get a 6. To the exponent of a 2, you get a 36. To the exponent of 3, you're going to obtain 216. So 6 raised to the exponent of 3 is 216. So meaning to say, these can be written in the base of a 6. 6 to the exponent of a 3. Once these bases are the same, it means these exponents will be equal. So therefore, our x will be equal to a 3. Once you see these bases, they are the same, exponents must be the same also. All right. Let us consider what we are given on D, because there's something that you must carefully work with. We are given 5 to the exponent of x plus 1 is equal to 125. Even though we have got an expression there, remember x plus 1, that's an expression. These were just terms. 4 to the x was just a single term. There we have got an expression. Do not worry about that. The concept is making the bases to be the same. So work with the bases. 5 raised to the exponent of x plus 1 is equal to. Can we write this 125 in the base of 5? Remember, 5 to the exponent of 3 is equal to 125. 5 times 5 to 3 times. So in place of this 125, we can write it as 5 to the exponent of 3. So like I said, if you don't understand this, take your calculator, raise 5 to the exponent of 1, you're going to get a 5. 5 to the exponent of, until you get this 125, you're going to see it was at what? 5 to the exponent of a 3. Now, using the concept that we had, we can see that truly these bases are the same. This base and also this base, they are the same. So meaning to say, we can equate the exponents. The x plus 1 must be equal to a 3. Take note, it's no longer a single term. It's an expression that we have there. But okay, let's just write, hence, as it is, x plus 1 must be equal to this 3 as it is. What type of an equation that you have? Previously, you're just writing x is equal to 3, x is equal to 2. This time, it's no longer like that. There is a number that is being added there. Remember your additive concept. How are you going to remove this 1 which is being added? We subtract that 1, but whatever that we do on the left-hand side must be done on the right-hand side. Remember, that was our concept from our previous class, our introduction. So meaning to say, by subtracting a 1, you have removed this. You are left with x. So x is equal to 3 minus 1, which is a 2. So now you have the x value which satisfies this equation. If you substitute x, which is 2 there, you obtain 5 to the exponent of 2 plus 1, which is equal to 125. 5 to the exponent of 2 plus 1, which is 3, is 125. Truly, 125 is equal to 125. Just like that. So you can even check that and see if you are in the right direction. So these are the typical questions that you can have. And in addition to that, they might just give us questions like, which is not an equation, just to copy and complete a certain table. They can be exam questions like that. So they are given a number, 2 to the exponent of x. That is, our x is this one. X represents these numbers here. X represents numbers 1, 3, whatever that you're given. And this is 2 to the exponent of x, meaning to say there we are given a 1, so it must be 2 to the exponent of 1. X is 1. So in place of x, you put a 1. So 2 to the exponent of 1 is what? That's a 2. Okay? Our x this time is 3. X is 3. So in place of x, you put a 3. 2 to the exponent of 3 is what? 2 times 2, 3 times. 2 times 2 times 2, 3 times, or just use a calculator. That will be 8. Same thing, 2 to the exponent of our x, which is 5. You multiply 2 5 times, you are going to obtain 32. You do the same thing on the other part, 2 to the exponent of a 7. Our x, there is a 7. That was going to give you 128. They just want you to fill in. Can you raise that to the power that you're given? The same concept here. You are given x. You need to find x there, given that this is a 1. So which x are we supposed to have? Remember, x represents what? The power. So it's 3 to the exponent of what? 3 to the power of what? Because x represents the power. But that must give us what? A 1. Which exponent are we supposed to put here so that we obtain a 1? Remember, from our exponents, any number raised to the exponent of a 0 is a 1. So x in this case was supposed to be a 0 in this, in place of x, you are going to put a 0. X represents the exponent. That's the part of x there. So x was going to be a 0 in that case. So it's like you're solving for x, you see now. On this item, you are given x, which is 2. What will be the answer there? 3 to the exponent of x, and we are given that x is what? Is 2. So 3 to the exponent of 2 is what? That's 3 times a 3, which is a 9. So meaning to say there we're going to have a 9. On this part, we are given the answer representing 3 to the exponent of x, which is 27. So 3, what is the x now? We do not know the value here. So just like the previous case, is 3 to the exponent of what? Which is going to give us a 27. Which number are you going to put here representing x so that your answer will be a 27? That is a 3. 3 to the exponent of 3. 3 times 3 times 3. That's a 27. So there we are going to have the 3 representing x. The power, x is the power. There we are given the power, which is 5. What is going to be the answer if the power is 5? So it's 3 to the exponent of x, and our x is what? 5. So what is the answer? That is the question. 3 to the exponent of 5 was going to give us 243. So there we have got 243. So they can give you a question under a table like this. But as we saw that in this case is like you are back to the solving of the equation, just like what we're doing on solving of the equation, because you do not know the value of x, but you know that 3, when raised to the exponent of x, it must give us the 27. So what is this x? So you can simply consider as we were solving these equations previously, as you can see. So we are back. Okay, if this is 3 to the exponent of x, what about 27? In the same base of 3, that is 3 to the exponent of x equal to 3 to the exponent of 3. So like I said, if these bases are the same, therefore the exponents will be equal. So x will be equal to 3. So as we can see, as you are filling in the table, you can also do it by solving of an equation. Solving of an equation can be like that. So it depends with the way that you understand it. But when filling the table, you can also consider the like the first case that I just said, like just look into the question, which number that you can put here so that your answer is a 27. Which number that you can put in place of x so that your answer is a 1. If you understand that way, you can also fill your table. So these are the typical questions that you are supposed to expect when working with your equations under these powers. We take them back from the concept of our exponents. As the bases are the same, the powers, which are the exponents there, are supposed to be the same also. So we can also put this as a conclusion to say if a is raised to the exponent of x is equal to a raised to the exponent of y, as long we can see that these are the same, as long these bases here are the same, it also follows that hence x is supposed to be equal to y. So it means that's an equation that you are going to form that you need to solve. So if 2 is raised to the exponent of x plus a 1, and we are given that it is equal to a number which is 16, we need the 16 being written in the base of 2 as the same base, 2 to the exponent of x plus 1. In the base of 16, the same 2 here. In this 16 here, in the same number 2 is same as 2 to the exponent of a 4. Once this happens, we can conclude from this concept to say that the bases here are the same. So also these exponents are supposed to be equal. So hence, x plus 1 is supposed to be equal to a 4. So if x plus 1 is equal to a 4, what will be the value of x? You are now back to your normal equations that we used to solve, where we can take this to the other side, or where we can simply subtract a 1 here, then subtract a 1 from the additive inverse, so that we obtain a 0. 1 minus 1, that's a 0, which is equal to 4 minus 1, which is a 3. We have got the x value, which satisfies the equation that we are given there. So let's work with more questions, more exam questions, so that we do understand how are they going to ask these questions. Just prepare yourselves for the exams that are ahead of time.